30 seconds. Okay, anyway, we can go.
All right. Good morning, everyone in Asia Pacific and in Europe, and good afternoon to everyone in Asia Pacific. We're very pleased to be here with an expert from TEKO, Maurice Robinson, the team leader at technical support at TEKO Refrigeration. Maurice has over 25 years experience in the retail and commercial refrigeration industry, and he is no doubt passionate about natural refrigerants and the technology. So we're very happy to have him presenting in our final session of the 24 hours of series of webinars focusing on the latest developments with natural refrigerants. The ATMO World Summit started yesterday. Some of you had a chance to listen actually to the very first of the series when our CEO, Maurice, has interviewed the CEO of TEKO, Andreas Mayer. It was very, very interesting presentation. So TEKO will be sharing, and Maurice will be kind enough to share some of their know-how and expertise and experience with CO2, presenting their patented technology and all the advantages and benefits that they bring to the industrial refrigeration and retail. So very happy to have you here, Maurice. Today, we were able to solve a little technical problem just in time. So very good to have you here. Thank you for joining us today, and we all look forward to your presentation.
Thank you for the kind introduction, Jan. Yes, as you said, I've been in the industry for all my life, so I'm very passionate about refrigeration and retail and industrial refrigeration. And you know, since the issues that we have with F-gases and the introduction of CO2, you know, I've been passionate about CO2 and the environment since then. So it's always, for me, you know, new technology is like a 5-year-old kid opening their Christmas present or their birthday present. You know, when I see new technology, I'm rubbing my hands together. I was always very happy when I was working with Corral, and a lot of times, you know, they'd send new products out and open in the box, and it was literally like opening presents. So thank you. Anyway, without any further ado, I think let's start the presentation.
Please. And you know, I will just add to something that we hear a lot last couple of years, is that there has been so much innovation in the refrigeration sector last 10 years, more than the 40 before. So it must be exciting for people like you who are truly passionate about this technology. Good times to be in the industry.
Yeah, it's an interesting job to have in a profession. It's every day there's something new. Every day it's a new project. It's really exciting to be part of this whole thing, and it's also exciting to be part of the change as well. You know, I think if we were just stuck on freons and everything was like normal, I think it would be pretty boring. But you know, this whole change that's coming about and making a difference in the world is it's very satisfying.
Absolutely, and you know, the refrigeration technologies present all aspects of our life. We hear more and more about the heat pumps and energy, right? Especially these days with you know all the geopolitical you know, difficulties. So we look forward to your presentation and your very interesting take on use of CO2 in industrial, which is increasingly popular in this sector. So please go ahead, share your screen, and we look forward to your presentation.
Yeah, great. Thank you. So just an introduction to EVALIFT, which is a TEKO patent. So I named this energy saving on an industrial scale because the energy saving is what we're going to be doing on the industrial side of installations. This has obviously already been tested, and I've got some slides to prove the test that we did on retail sector, but this can work from small all the way up to large installations. So CO2 has become the preferred choice of refrigeration. We all know that by now. We don't have to, you know, we're not at the stage where we're trying to convince people to use CO2. Everybody is using CO2 already.
Maurice, sorry to interrupt you. We don't see your screen. Could you please?
Oh, you don't see the screen.
Oh. Make sure that we share your presentation. We see you on the main camera. If you can please try the screen share again.
Okay, give me 2 seconds.
No problem. Take your time.
Sorry, our computers.
We have the presentation too.
Okay. Okay.
Okay, great. We have the visual. If you can just go full screen, then we are ready to go. Fantastic.
There we
Thank
go.
you.
Okay. Okay, all good?
I would
Okay,
just say there is a possibility to, we now see two of your slides. We also see the next slide. There will be possibility to display, I think it's the display setting on the very top, on the left. Yes, there might be possibility to, next to it, on the right. There might be possibility to switch to this main window only.
Okay.
Yeah, please. Yes, perfect. There you go.
Perfect.
No more interruptions
Okay.
from me, I promise.
Okay, there we go. Now that we've got the simplest of technology sorted out, we can go into the easier technology. Okay, great. So as I said, CO2 has become the preferred choice of retailers and installers throughout the world already. So since the adoption of CO2, a lot of companies have invested into making things more efficient, which reduces operational costs. In the beginning, CO2 was very expensive, but as time has gone on, you've seen that the cost of CO2 has come down a lot, and it's actually sometimes a lot cheaper to put a CO2 system in than it is a Freon system. Fine-tuning the designs for lower capital costs, so we don't need as many ball valves, we don't need as many plate heat exchangers. So everything gets taken out. You know, everybody in the beginning of CO2 wanted to put everything into a system to make sure that it was safe and everybody was happy. But now, because we know it so well, we can actually start stripping little parts out of it that we don't actually need and making it a lot cheaper and a lot more cost effective to put in. A lot of the companies on the compressor sides have invested into R&D, and they're producing larger kilowatt systems as well. So, you know, with the larger kilowatt systems, instead of having, you know, 10 or 15 compressors needed for a rack in an industrial scale, now we can only have 6 compressors. So that's really boosting the market from retail into the industrial sector. So I think anybody who dialed in yesterday and watched the presentation of our Managing Director, Andreas, saw this slide. So this is a percentage of F-gas versus CO2 in our production here at TEKO. You can see in 2012 all the way up to 2021, and it's a complete opposite. And, you know, I think last year we did 3% of Freon compared to, you know, almost 90% in 2012. So there's been a complete change around in that. So I think everybody who's seen a TEKO presentation has seen this slide, but it's a good indication of what's been happening in the CO2 market. However, I want to point out, and this is industrial applications that's more than 250 kilowatts. This is the opportunities that we've had since 2017 to 2021. So 2016, we actually didn't have any inquiries at all for more than 250 kilowatts. So 2017, we had 7, and then in 2021, we had 185. So that's a very, very good growth for applications over 250 kilowatts. So 250 kilowatts, I think, is on borderline between retail and industrial. So I think the next slide will show you going to 550 kilowatts rack on its own. In 2017, we have the same growth, and we went from 1 inquiry in 2017 all the way up to 38 in 2021. So, you know, the opportunities for large industrial applications is becoming a lot more popular. And here at the TSP at TEKO, you know, we've got a whole team of people that's working mainly on industrial applications and opportunities at the moment. The standard stuff that comes into the factory and goes out is just, you know, day-to-day business. But, you know, the specialized equipment that we're doing, you know, we've almost got a team of people just working on industrial applications. So this is just a snapshot of our rockstar industrial CO2 multi-compressor system, all the way up to 960 kilowatts. We'll go a little bit deeper into that at the moment. But if you have a look now, what we're introducing is a power of EVALIFT. So EVALIFT is a TEKO patent that's been patented since about 2019. But what EVALIFT does is it gives you more operational safety and lowers your energy costs. So this is one of the main benefits of EVALIFT. So what does EVALIFT stand for? EVALIFT is evaporation and lifting. So lifting the evaporation temperature and then lowering the superheat to a semi-flooded evaporator. what that does is we just move the superheat away from the evaporator, and then we control the superheat actually at the pack with a plate heat exchanger that's specially designed. So as we know, the superheat on a standard system, ranges between, I don't know, 6 and 10 K. Mechanics and service technicians are scared to lower that, because we all know what happens if we have a low superheat on an evaporator. We end up having flooding back to the compressor damage, oil damage, foaming of the oil, which creates damage on the bearings and so on. So we have to keep that superheat high or higher to make sure that we don't have any issues. But with EVALIFT, we don't have to worry about that problem going forward. So EVALIFT is efficient, safe, and simple. So this is the nice part about EVALIFT, is it's actually very simple and straightforward. You don't need a university degree to actually understand this, which is good for me. Considerable increases of cooling efficiency. So you get maximum cooling efficiency out of your evaporators. It works for medium and low temperature. And that's one of the points that I want to get across to everybody today, is that, a lot of the other systems, ejectors and so on, they work on medium temperature, but because of oil systems and oil problems, it doesn't work normally on the low temperature side. But with EVALIFT, it works on medium and on low temperature, so you don't have to worry about that. It's a very simple and yet effective solution. There's not many technicians out there that won't be able to walk onto the site from not knowing it and then understand how it actually works. You don't need any specialized training on the system. It's very simple and straightforward. A few parameters on the control side and a little bit different piping work on the rack side. And that's all it is basically. We've had a patent since 2019. So the nice thing is bringing the superheat down to almost 0 K. So we have a flooded evaporator. This enables the whole evaporator to actually be used instead of wasting that superheat as part of the evaporator. The technology basically is a specialized and specifically developed heat exchanger for this type of system, and a very smart control system. Additional benefits of the EVALIFT system is a higher system stability, so your system becomes very stable. The operation is also very safe as well, so you don't have to worry about having any issues with your rack, and you have a longer lifetime of the whole cooling system because of these factors. So just to give you a little bit of a infographic on the effects on the compressor. So as we know, if you have a suction temperature at -9, the compressors basically have to get that gas all the way up to 36 degrees on the other side, so that it can go through the whole cycle again. So from -9 all the way up to 36, you've got a very high delta that you have to make sure that the compressors are pumped. So you're going to need, let's say, 3 compressors. With EVALIFT, or with just increasing your suction temperature from -9 to -4, you might only need 2 compressors. So it actually benefits you, and you can see the benefit even on a desktop simulation. So having a look at the pH chart, you can see that just increasing the full evaporator surface creates a smaller DT, and there's a higher temperature output. And the rule of thumb for this whole thing is 1 K less superheat gives you 1 K higher evaporation. So when you drop your superheat, you can increase your suction temperature. So as the one goes down, the other goes up. And the closer you get those two together, the better you're going to have on your energy saving. So the effect is a higher evaporation temperature and lower energy consumption. So Zerocode superheat, as I said, we're utilizing the whole evaporator, and it's independent of pressure difference. So this doesn't make a difference at all. So decreasing the superheat and using the full evaporator works on all loads as well. So it doesn't matter whether it's a full load or a low load. So in other words, day or night. It doesn't matter if it's summer. It doesn't matter if it's winter. The benefits of basically are year round, and there's no influence on ambient conditions. The system is basically working flat out day and night, 365, 7 days a week. So this is what actually happens on the evaporator side. So you can see that on the evaporator, we normally have the superheat. So what we're doing is we increasing that or decreasing that superheat down to 0 K. And then we're using that cooling effect on the other side, which is on the gas cooler outlet side, to cool down the gas cooler outlet temperature as well. So you're winning on both sides. So it's optimally adjusted gas cooler at the compressor. You have lower flash gas as well after the high pressure valve. There's less liquid content after the medium pressure as well. Lower flash gas and less oil foaming as well. So constant compressor conditions, your compressors are protected, and low temperature deviations and a much smoother operation of the entire system. Because we're controlling the superheat of the system, we can actually make sure that we don't have large deviations in suction temperatures and discharge temperatures and so on. So it really, really works well. So specifically designed plate heat exchanger for the MT and LT suction line, an intelligent control system and algorithm, and one standard three-way valve. So that's, when I say it's simple, that's all that's added into the pack. So it's very, very cost effective, first of all. And second of all, it's very, very, very simple to understand. So with the improvements of the operational safety, higher stability, monitoring and achieving optimal suction conditions at the compressor inlet, so the best operating conditions for long service life. So this actually extends the performance of the actual pack a lot longer than what it would normally, where compressors may be running outside of the envelope. And the lubrication system is also not compromised at all. So it doesn't matter how the system is running or what condition it's running in. Your oil is always being separated. It's always going to the right position. There's no foaming in the compressors. There's no oil transfer, and you have a much better oil return and an oil feed. So having a look at the energy savings, increase in the efficiency. So you have a more usable surface area in the evaporator. So if you increase the suction temperature by 3 to 6 K, this is what happens. So as a rule of thumb, it's 4%, 4K or 4% per K more efficient in every system. So if you have your suction temperature risen by 3K, then you can expect an average of 12% energy saving. If you increase it by 6K, you can expect a 24% increase in energy saving. So depending on how far you can push the system is how much energy saving you'll actually achieve. So having a look at the control system. So the control system is a very special and intelligent control system. And what it does is it's monitoring the whole system real time every 5 minutes. So what the controller does is it has a look and says, okay, where are my evaporator settings at the moment? What is my superheat? And where are we at our superheat control? If all the evaporators are happy, then we can say, okay, cool, we can reduce the superheat, and we do this obviously slowly. We reduce the superheat down to as low as possible. At the same time, as we reduce the superheat, we are telling the rack controller to actually increase the suction temperature. So as the one comes down, the other one comes up, and we try and find the happy medium at that time with the correct ambient conditions and the correct performance of the system, how the store is trading, what the store temperatures are. All of those influencing factors are all considered, and we basically get that as close as possible so we can get the maximum energy saving. The nice thing about this is that the system is actually always fine-tuning itself. So with a normal system, you install the system's working, and you can walk away. And within a year or two, after you've had 20 mechanics through there doing their little intelligent part that they feel is better for the system, you end up having a system that's not fine-tuned anymore, and it's not running as well as it could. Where with EVALIFT, it's actually trying to always find its perfect conditions. So it's fine-tuning itself. So just to clarify, raising the suction temperature, just to give you an idea, we all know that the compressor sucks the superheat of gas. But if we have a look at a summer condition with a 89 bar and a gas cooler outlet temperature of 36 degrees, running at -8 gives you a COP of 1.69. If you take those same conditions and you run it at -3, you've got a COP of 2.07 already, which means you've got a 22% energy saving straight away just by increasing that suction temperature. In the winter, with when we have non-transcritical conditions, and in subcritical, if we have the same conditions at -8, the COP is 5.4, and at -3, it jumps up to 7.45. So you have a 37% increase then. So depending on winter and summer, you're still saving around about 20%. You do save a little bit more, but the constant is always there. So just to illustrate that, this is a graph of Frankfurt, which is where I am at the moment. And this is the temperatures, the outdoor ambient temperatures in hours per year. And you can see that on the left-hand side, we've got the kilowatts of how much it's used, and then the temperature range at the bottom. So you can see the average temperature is normally running around about 12 to 18 degrees, but that's 18 to 20% energy saving is always there. So this illustrates that, you know, you can use a system summer, winter, it doesn't make a difference. You're still going to get the energy saving. Right, so I just want to compare some items with regards to EVALIFT, and just to explain the simplicity. And please don't get me wrong, gas ejectors and liquid ejectors, you know, we install both, we manufacture for both. They do work. I'm not saying that they don't work. They're very good technology. However, they can be a little bit complicated when it comes to, for instance, the oil system. You need special designs and special installation pieces for the actual oil system when you're using a gas ejector or a liquid ejector, where with EVALIFT, it's a standard oil system, so any mechanic would actually know how to use it. All of the ejectors and EVALIFT can all work with medium temperature and low temperature. You can't use a gas ejector, you can't use a liquid ejector, but on EVALIFT, you can use low temperature. So you're getting the savings from low temperature and medium temperature. Parallel compression is needed for gas ejectors and liquid ejectors. For EVALIFT, if the ambient conditions call for it, then you can have a parallel compressor to add to your savings. But if the ambient conditions don't call for it, then you don't have to put it in, but you can still use the EVALIFT system. High ambient conditions throughout gas ejector, liquid ejector, and EVALIFT, for everybody happy. Low ambient, the gas ejector doesn't perform and not used. Liquid ejector can perform on low ambience, but so can EVALIFT. Experience and know-how, this is quite important. So a gas and a liquid ejector is a little bit complex for certain mechanics, but with EVALIFT, it's very, very simple and straightforward. You know, you can open the book up and it can explain to you exactly how it works. It's very, very simple. And then also with regards to CapEx. So the gas ejectors on a medium, if I compare the three, gas ejectors on a medium, liquid ejector is high because there's a lot more equipment that you need to put in to use that type of ejector. But with the EVALIFT, like I said, it's very simple. It's 1 or 2 plate heat exchangers, a 3-way valve, and then the control system, which you put in anyway. The easy to understand functions and complex technology. So EVALIFT is technically simple solution. So this is what I'm trying to get across, is that it's really, really simple. Liquid or gas ejectors, you know, you have multiple packs of ejectors, especially when you start going into the industrial field. When it's a smaller installation, it's a lot more simpler because there might be 1 ejector or 2 ejectors or 1 bank of ejectors. With EVALIFT, there's heat exchanger with a 3-way valve, but with liquid and gas ejectors, there's several 3-way valves and 2-way valves. The regulation for EVALIFT with the control loop without setting parameters. So the oil ejector, there's quite a lot of parameters that need to be set in, and sometimes it's a little bit confusing for the mechanics. But know-how for users is very, very simple. And, you know, liquid ejectors, you know, you need to have a little bit more training if you're going to be using liquid or gas ejectors. So with regards to independent technology versus technology with limitations. So with EVALIFT, there's no parallel compression required. So it's not necessary at all, like I explained. With ejectors, you have to have parallel compression. EVALIFT can be used for medium and low temperature, where with ejectors, you can only use it for medium temperature circuits. The EVALIFT can be combined with a variable ejector. So we've also got a system called TEKO jet that we can install with EVALIFT, which will give you that added extra energy saving. And there's an increase in operational reliability where there's no improvements. It's the operational reliability just stays the same with the ejector. And the high unit stability, which is an important part for any, you know, retailer or end user. And the ejectors, you know, there's no improvement on the stability of the system. So having a look at some data, so I just want to show you the difference. This is a small store with 55 kilowatts and 2.5 kilowatts of low temperature, and 55 on medium temperature. So we compared a standard booster, and we installed the EVALIFT in a store that was very similar. The energy consumption, the kilowatts and hours on the standard booster was 77,162. And with EVALIFT was only 66,945. Now just remember, you're saving on both sides. So it's the low temperature and the medium temperature. However, the low temperature is obviously not going to give you that much saving because you've only got 2.5 kilowatts. But saving kilowatts and hours per annum was 10,000 kilowatts. So if we convert that into euros, we're saving 1,736 euros. The additional investment for the EVALIFT, like I said, with the plate heat exchangers, the controls, and the three-way valve, it only takes 3.5 years to pay that system off. And just remember, that's a small system. So having a look at a medium system, so 80 kilowatts and 16 kilowatts low temperature, the standard booster used 125,373. And with EVALIFT, 108,620. So you can see as the increase in kilowatts, the return on investment starts coming down because you can see here the investment was only 7,423. So we're saving 2,848. So we've only got a 2.5 year payback period. So having a look at a 150 kilowatt system, medium temperature, and 50 kilowatts on low temperature, and including parallel compression on these ones. So we had a standard booster system. Kilowatt hours per year was 216,000. EVALIFT was 187,000. Gas ejector 208. Liquid ejector 195. And including EVALIFT and TEKO Jet, we got to 182. So the TEKO Jet and EVALIFT was obviously the winner. But you can see at the bottom, when I have a look at the return on investment, I'm not going to go through all the other figures with you, but you can see the EVALIFT would take just over 2 years to pay itself off. Gas ejector was on 4 years. Liquid ejector was on 4 years, and the TEKO Jet was on 2.6 years. This is because of the difference in the additional investment. I'm not saying that EVALIFT doesn't outperform, because it normally does on larger systems compared to a gas and a liquid ejector. But you can see the payback period because you know, the simplicity is what's the main goal over here. So having a look at the effects again, coming back to that little picture that I had. So for -9, we would, you know, normally have 3 compressors running. At -4, one of the compressors will probably drop off. And then just to clarify with the parallel compressor support, you know, from +2, then we would increase the energy saving over there. So if you take all of the combinations together, you've got a really, really efficient plant. Right, so we've got some field data as well. So we had a look at 17 hypermarkets. And we compared those to 2 TEKO projects with EVALIFT. So we had some in Austria and then obviously around Germany. These were all local, obviously. And then, so there was a total of 17 MT systems and a total of 12 LT units. So what we did is we compared the saturated suction temperature, we checked the superheat, the loads, the parameters. We had a look at all of the data. And then we had a look at that data, and we took a time frame of 1 week, the average of the minimum and maximum. And then we plotted that data in 1 minute intervals, and then we had a look to see where everything was. And then we took the average of the whole thing. So having a look at the average of the 14 stores, we had a average suction temperature of -8.9 on the medium temperature. And on the low temperature, we had an average temperature of -32.2. The 2 stores that we had with EVALIFT, you can see that our MTs were running at -5.7 and -4.4, and our LTs are running at -30 and running at -27.6. So you can see there was quite a big difference over there. So that live data results had an increase of over 3 to 4K, and that resulted in 18% energy saving. Just to you know emphasize how much energy we saved over an average of 14 stores. Right, so EVALIFT, simple for industrial applications. So it's simple in setup and control. And now we're talking industrial applications. So there's a lowest additional cost out of all of the type of technology we have today. There's a high energy saving. Your return on investment is fast. And the main thing is it can work on low temperature and medium temperature. And at the same time, you don't have to worry about ambient conditions either. So it can work in any ambient conditions. Obviously, if you add the TEKO jet in very high ambient conditions, then we can get a much greater benefit. However, in the standard applications and in large applications, you're going to have the best energy savings. The system can also be retrofitted to any CO2 evaporators as well. So, you don't have to worry about special evaporators. In the initial design, it would be nice to be able to size the evaporators and design them correctly for flooded or semi-flooded applications. But it's not necessary whatsoever. You can use standard evaporators, no problem at all. So the Rockstar, this is another picture of the Rockstar, up to 960 kilowatts. We've got the industrial Rockstar series. We've got the G6. We've got the Smart 2.0. So we can go all the way from a small system all the way up to a 960 per pack kilowatt system. Medium and low temperature cooling, heat recovery, heat pump and air conditioning, with options of parallel compression, EVALIFT and TEKO jet. And it's a modular design as well. So you can actually take the intermediate pressure part of the system off if the pack is too long to get it in, so it can actually be separated, which is quite a good option. And that's it. Thank you.
Thank you very much, Maurice, for your presentation. Very interesting and very relevant to what's happening in Asia Pacific as the latest trends.
Yeah.
I have a couple of questions for you. Maybe we can start with it. And then
sure.
I see the first question from our attendees, and I would like to encourage the others to also submit their questions to Maurice. So you have a very unique opportunity, and this is the final of the webinars of the World Summit. So please go ahead and submit your questions. Maurice, one I would like to ask, we are now on Asia Pacific time zone. We are talking to the audience in Japan, Australia, Southeast Asia, China. Most of this, let's focus on Southeast Asia. This is, let's say, the market when the CO2 is least developed so far. And most of these countries are experiencing very high ambient temperatures. Can you share your experience with the high ambient temperature CO2 projects and installation that you have conducted last couple of years? And have you tested the EVALIFT in these conditions, and how would they perform? Something that would be more relevant, let's say, to the Southeast Asian audience. Thank you.
Okay, no problem. So if you have a look at the actual system itself, it's not really dependent on ambient conditions. So I think you need to separate the thoughts between the two. So the EVALIFT actually saves you energy regardless of the ambient conditions, because it's flooding the evaporator rather than doing something with the ambient conditions. We all know that the lower the ambient conditions, the lower that the energy will use. But if you compared two systems, let's say in the same ambient conditions, then what you would have is you'd have a much better energy saving on the EVALIFT side, because you're flooding the evaporators. You're not doing anything on the environment or on the ambient side. So basically, if these systems were installed in a high ambient conditions, that would be a separate part in design. So then we would use different types of technologies like spray systems on the gas cooler. We also have a benefit with the EVALIFT, because as we come out of the gas cooler, we are actually cooling the gas down with the gas that we're getting back from the evaporator. So I think you've got to separate the two and just think of it that way. So the ambient conditions will always be the same, but there's a lot of methods. We can add the TEKO jet into the system for when the temperatures are very high. But there's multiple solutions that you can do. You can have cooling towers, you can have spray systems, you can have the systems that have wet pads on them for the gas cooler side on the high ambience.
Okay.
Yeah.
Thank you. I have one more question, and then we can tackle the questions from the audience. The reality in Southeast Asia is that in industrial refrigeration, it's either ammonia or it's the HFC systems that are being deployed. In your comparison, you have been comparing most of the different configuration of the CO2 system, right? Can you comment on how would the EVALIFT, let's say the latest iteration when it comes to your technology, compare when it comes to the return on investment with the HFC system or ammonia system? Do you have any information on that?
No, so we haven't done any calculations comparing CO2 to ammonia. However, in my experience, I have been involved in quite a few large industrial projects around the world, and mainly in South Africa. And when it comes to comparing ammonia to CO2, there's always this little bit of a, especially in the atmosphere events, there's always this little bit of a hassle between the ammonia guys and the CO2 guys. But at the end of the day, CO2 has a position in the market. Ammonia has a position in the market. When you're talking 10, 15 megawatts of cooling, the industrial guys with ammonia, I think would win hands down at the moment. But CO2 was generally started off being just a small type of solution for smaller retail stores and supermarkets. But as we've come along and as technology has grown, we can see that this can be used in industrial sectors. And in fact, there's multiple projects around the world that are 4 or 5 megawatts of CO2 refrigeration. There's good things about CO2, and there's bad things about ammonia, and there's good things about ammonia and bad things about CO2. So it depends on what the project is, where the project is. If it's next to a hospital, a lot of times people would rather go for something that's not toxic, for instance. So there's a lot of different aspects. It doesn't matter where it is. It depends on the design, I suppose.
Thank you. Excellent. And one of the examples we are hearing from China, but also other parts of Asia, is really the natural refrigerant systems, the ammonia systems, the CO2 systems sometimes do get to compete with very low price and very old HFC technology. And that's, I think, that's the challenge that we have as an industry.
Yes, of course,
be the CO2, be the ammonia, whether our hydrocarbons are entering the stage on chill side as well, right? So it's really how can we leapfrog the HFC solutions in the first place?
Yeah, definitely. And I think, CO2 is a good start to leapfrogging anyway. The costs are really, really good when you compare to other type of natural refrigerants in the industrial sector. When you talk about an ammonia system, for instance, there's a lot of things that you need to install, showers and eye washers and things like that, where you don't need that with CO2. So there's benefits for both systems. As far as I'm concerned, if you go natural, hey, great for you. We produce ammonia systems here at our subsidiary in Poland, Frigopol. So we all for naturals. At the end of the day, it just depends on what's going to fit for what project. So you have to have a look at each project as you go along.
Absolutely. So let us start with the questions from the audience. First question from Patrick Clardy. Do you need a liquid separator in the suction line to protect the compressors?
No, you don't. So I knew that question was going to come up, but no, you don't.
Okay, good.
Yeah, we control that with the plate heat exchange and the three-way valve to make sure that there's no liquid going back.
Excellent. That's the first answer. The next question is from Davy Creel. Is there any risk for liquid carryover with incorrect settings?
So I suppose with any setting that's incorrect, hello, Davy, nice to hear from you. He's an old colleague from South Africa. So with any settings, if you by mistake set a superheat on a controller or a normal system down to 1K, you're going to have some liquid carryover. So there definitely is a problem. The nice part about this type of system is we're monitoring what's happening at the pack. So we know when there's going to be when there's liquid coming back to the system. We have a three-way valve that is controlling the suction temperatures. So there's always a risk. It doesn't matter what system you have. There's always a risk of something happening. However, the control system, because it's working every 5 minutes and it's making sure that the system is fine-tuned, we shouldn't have any issues. And all of the systems that we've done so far, we haven't had any issues at all.
All right, thank you. Then next question. TEKO is based in Germany, right? The largest number of projects you have is in Germany and Europe. Can you tell us about your presence in, outside of Europe, in the Americas or in the Asia Pacific? What's your presence? How many projects you have?
Yeah, so I mean, we're working on quite a few projects at the moment in South America. We have projects in France, Italy, most of Europe, and we also have now TEKO Thailand. So we new in the market there, I would say. But we're coming in strong, and we're doing quite a lot of opportunities there at the moment in the east. So obviously, if anybody in the APAC region, if they need anything, we do have an office there in Thailand.
Excellent. Do you consider manufacture CO2 transcritical in Thailand in your subsidiary or factory as well?
Maybe eventually, not at the moment, but eventually we will.
Okay. Interesting. And when it comes to Asia Pacific, you're looking for new opportunities across the board. Is there any specific markets that are of an interest to you?
No, as a manufacturer, like I said, we can manufacture anything from a 3 kilowatt system up to 960 kilowatts. So the field is open, and if anybody has any inquiries for any application, like I said before, we've got a whole team of people here that is working, a 9-to-5 job on designs and everything that's got to do with specialized equipment and sizing of large systems and large industrial systems. So whether it's a small or large system, it's not a problem at all. Excellent. So we love any inquiries, really.
Okay, that's good to hear. And allow me to ask, we have reported about some of the first systems that you have provided to Israel. And yesterday, Andreas mentioned that these have been quite successful. Can you tell us a little bit more about, what is it like to bring the first system in the country? Do you help train the industry? What's kind of the startup, plan for CO2 in the new market?
Yeah, so a new market's always difficult because of the level of education. So sometimes the level of education is a bit of an issue. However, when you have a look at what we do, pre-COVID, TEKO was training more than 360 people per year in our in-house training on CO2. COVID's, put a little bit of the brakes on us because it's a bit difficult to have a lot of people in one room. And obviously the risks are a lot higher as well, considering that we are manufacturing plants, and we can't have COVID breakouts. Andreas explained yesterday how horrible it was that for 2 years we had nothing, and then last month we had 60% of our manufacturing on sick, with COVID. So there was a lot of issues with that. But when we approach a new market, we approach the market as if the market was bare and they never knew anything. We welcome people and bring people to our head office here for training. We have local representation there, not only on the sales side but also on the technical side. So all the different branches that we branching out worldwide, we have the correct people there, and we have people from our head office that travel around and do training as well. So that's not a problem at all. We investigate in numerous countries at the moment, and we go through. Unfortunately, with COVID, we have to start off with a Teams call and a Teams discussion, and but it gets the ball rolling at the end of the day. But we've got a full setup for training here, and we want to train everybody. We really don't want to keep any secrets to ourselves. If people want to come and do training from our opposition, you're welcome. Make a booking on the website. It's no problem at all.
That's great to hear. And my question is about what's you have been in the industry for 20+ years. You've been working with Carol, right? You mentioned before quite a lot of CO2 development has happened over the last 10-15 years. What's next for CO2? How do you see the next 5-10 years in the industry? I mean, CO2 has come a long way. We now talk about the systems over a megawatt of capacity. So what's kind of the next stages in your opinion?
I think, as time goes on, a lot of developments in certain sectors had a little bit of a pause for many years. But with CO2, it seems to be like we've started this journey, and we were just compressors on LC and compressors on MC, and we had a problem with the CO2 equator. Then we had parallel compression came out, and that CO2 equator moved up a little bit. And then we had this technology. We've had other manufacturers that have got other technologies, ETE, FTE, all the different E's. We've got ejectors coming out now. And in our own R&D lab over here, we're going great guns. We've got some really, really cool developments coming out very soon, and some cool patents. So I believe that all the companies around the world, and in Europe specifically, because CO2 is becoming so popular, are putting a lot of their efforts and a lot of their money into R&D around CO2. So whether it's in the control side or it's in the mechanical side, you have companies, manufacturers like the compressor manufacturers coming out with higher capacity compressors, or compressors that are much more efficient. So I just believe the technology in CO2 is just going to keep growing and growing and growing. I think everybody's just, it's the way forward. It's a future-proofing your system at the end of the day. You don't have to worry about, is it going to be phased out in a few years' time, or oops, we've made a mistake, it's destroying the atmosphere again. There's none of that. So, I think CO2 is just going to go leaps and bounds, and it's exciting to be part of that.
Absolutely, and we have presented earlier today about our project in Philippines, when together with our project partners, UNIDO, and the local ministries and the governmental training organization TESDA, we are working on a culture innovation hub, and TEKO has also joined as one of the contributors, precisely with to contribute with your know-how, with your expertise, to be able to help train the local industry. So one of my final questions would be, what would be your message for the industry in countries where CO2 is not yet established? There might not be any projects running yet. There might be some hesitancy. There might be some kind of, but for us it's different because of the ambient or other reasons. What would be your message for the industry when we don't have yet established examples of CO2 transcritical?
Sorry, I lost you there. Can you just repeat the question?
No problem. What would be your message for the industry in countries when CO2 is not yet, a standard, or not yet? There's no first projects. There's no experience yet with the system. Okay,
just do it. It's quite simple. You can't hold on to the old for very much longer. Eventually, manufacturers around the world are going to stop producing. We used to produce a lot of Freon systems, for instance, and our stock was full of Freon. Now we get an inquiry for a Freon system, and we're like, geez, have we got the parts? No, we phone. No, it's going to be 15 weeks or 40 weeks, or, it's really difficult to get the parts. And eventually that's going to happen with the whole world. You'll still get the black market equipment and so on. But I think, going forward, just, do it and start the process. And once you start the process, and the ball just keeps on rolling, it's like a snowball. Everybody's happy because, I think in the beginning, people were scared of CO2 because of the pressures and everything, and everybody was so scared, and they had 15,000 safeties on the system. Now guys walk into the plant room, and, it's just second nature. The system, it works, and it's natural, and it's future-proof. So, if you're in the design phase at the moment, it's best to start thinking about it, because in 10 years' time, you might not be able to refill the system if you're going to use a Freon.
Thank you again, and we will make sure that this year we will bring Philippines on the CO2 global map as a country when we have running a transcritical system, and hopefully the other countries in Southeast Asia and the rest of the world will follow.
Yes.
So,
okay.
Maurice, thank you very much. Great presentation, a lot of interesting information. And again, I think the industry is noticing that this solution for industrial is here to stay. And it's good to see so much development on the side of increased efficiency, reduced cost. That's the direction that the industry is of course, asking for. So thank you again. It was a pleasure.
And I think Darby also made a statement there. if I can just read it out, he said the combination of a CO2 and ammonia is a very good technology to consider as well. This way one can get best of both worlds. He's definitely correct, you know, hit the nail on the head, you know, very, very good. But, you know, every system has a place in the industry at the end of the day.
Well said. We are hearing that the factory in TEKO is getting really busy, so it's another good sign of the business taking off.
I forgot to put the do not disturb on the door handle.
You know, it's a sign of a good business. You guys are busy, more systems than ever. That's what we want to hear when it comes to refrigerants. So it's a good sign. Yeah. And thank you again. This was
my pleasure.
It was our last presentation in the whole ATMO World Summit 2022. So it was a pleasure to work with you. Thank you to everyone who attended. And we are now ready to close the session and the 24 hours of webinar. So we will definitely be back. And this recording will be available in the next 2 minutes, basically on YouTube. So we will have more people following this. We will be covering in our articles. It was live streamed on LinkedIn as well, etc., etc. So we'll make sure that your message is reaching the right audience. And thanks again for joining us.
Right, no problem. Thank you.
Audience.
Thanks very much.
Everyone have a good day.
Cheers.
And enjoy your day.
Bye.